Hello, I have my chromatography test. Oh my god. So we're gonna do chromatography again. Oh my god. Okay. First question says, a not accredited food safety laboratory is analyzing a new formulated citrus energy drink. They must quantify the concentration of two specific ingredients to ensure that the labels are correct or accurate. Caffeine is a relatively large, thermally stable but high polar alkaloid compound, and limonene, a very small, highly volatile, completely non-polar carbohydrate that provides the citrus flavor. And the questions, okay, that's the scenario, and the questions say, well, the first one says to justify which specific chromatographic chromat chromatog chromatographic technique, GC or HPLC, is strictly required for analyzing caffeine, and which must be used for limonene. Refer directly to physical properties of the molecules. Okay, so basically, caffeine, this is relatively large, thermally stable, but highly polar alkaloid compound. It's large and highly polar. If it's highly polar, that just means they either have hydrogen bond or dipole bond, and really apparently it's highly polar, which means the force is really strong, which means it would want to stay a solid or liquid instead of a gas. So it have very low volatility. I think that's how you say it. It doesn't have high, but it is not highly volatile. It is not very volatile, which means that you can't use GC anymore. So as caffeine is highly polar, it will not it will not be very volatile, making preventing GC to be used. So high performance liquid chromatography must be used with limonene being very volatile, allowing GC to be used. Alright, for the second part of this question, it says a junior technician attempts to save time by running a non-polar limonene sample through a reverse phase high HPLC system instead of the correct machine. Describe the relative polarities of the stationary phase and the mobile phase in the reverse phase setup. Well, the stationary, because it's reversed, normally stationary is polar, so now the stationary phase will be non-polar, and mobile phase will be polar. Okay, And part C says predict whether the limestone retention time will be extremely short or extremely long in this reverse phase system, and justify your answer using intermolecular forces. Okay, so as limonene is completely non-polar, it will have extreme high affinity towards the non-polar stationary phase, causing the retention time to be extremely long. Okay. Moving to the second question. Second question says, an organic chemist is using thin layer chromatography to separate a mixture. The stationary phase is a standard highly polar silica gel plate. For the first run, the chemist uses a mobile phase that is 100% hexane. They spot a compound X highly polar and compound Y nonpolar. Compound X have a RF of 0.05, compound Y have a RF of 0.85. For the second run, the chemist changes the mobile phase to a 50-50 mixture of the hexane and ethanol. Ethanol is highly polar. They spot the exact same compound on a fresh silica plate. Explain the specific intermolecular interactions that cause compound X to have such a low RF retention factor. Retention factor value in the first run. So basically, as compound X is highly polar, it will be very attracted to it will be very attracted it will be highly attracted to the it's highly polar and will be attracted to the polar stationary phase. Okay. This causes compound X to not want to move up with the non-polar solvent solvent as much, making its RF low. And that's part A. Part B says predict exactly how the RF values for both the compound X and compound Y will change for the second run. So basically, Well, for the second run, there's more, so the solvent will be more polar, which means that X will obviously move up more. So compound X's RF will increase while compound Y's RF will decrease. And then for part C, justify your predictions by explaining the new intermolecular forces at play between the mobile phase and the stationary phase and the compounds. So basically, compound X will be more attracted to the more polar mobile phase than the first trial, increasing its RF compound Y will be less attracted to the more polar mobile phase, decreasing the RF. That's basically how it works. You can expound this a little bit more, but that's basically how it works. So, oh well, bye bye.